All right, let's see if we can give this a go. There's a whole lot of stuff on the board here. We're talking about what the issue I think you're having, which to be honest, I had a little bit of an issue with, as well as figuring out what in the world does this mean in this problem. And it comes from, it's kind of a shortcut for higher order chain rule. So let me, and I hope that I use the same kind of language that Stuart uses. I'm more of a Larson guy, but let's see if I can make some sense out of this, and you can make some sense out of what I'm saying. Chain rule, first of all, we know that chain rule is for derivatives of composite functions like f of g of x or f of g of x. If we want to find the first and second derivative, well, the first derivative of a chain rule is the derivative of the outside global function times the derivative of the inside function. For example, if we have a function h of x equals 6 times 2x plus 5 cubed, then the first derivative of that is going to be bring the 3 down times the 6 gives you 18, times that inside function unchanged to the 1 less power, times the derivative of that inside function. Right? That's what the chain rule says. And we can simplify this. 2x plus 5, the derivative of that is 2. 2 times the 18 is a 36. 36 times 2x plus 5 squared. Now, if we wanted to do that again to find the second derivative, well, we could just differentiate this again. 2 times the 36 gives you a 72, times this thing to the 1 less power, 1 less than 2 is 1, times the derivative of what we were squaring. The derivative of that, 2x plus 5 is 2. 2 times 72 is 144 times 2x plus 5. And that's great. However, that doesn't allow for us to have a formula for the second derivative. That's just applying the first derivative twice, not jumping to a second derivative. So what math people have done is they have said, well, if this is true, it's the derivative of the outside function times the derivative of the inside function, let's differentiate that. And, well, that becomes a product rule, right? If you have two things multiplied together, let's differentiate. So the second derivative of our original function is the first derivative of the derivative, the second derivative. So we're going to use the product rule. And here's where I don't know the order that Stuart uses. I think you're using a Stuart book, right? If you're not, whatever. But the gist of, because it's a commutative, multiplication and addition are both commutative, I have this set up as the derivative of two things multiplied together is the derivative of the first times the second plus the first times the derivative of the second. I've always said first times the derivative of the second plus the second times the derivative of the first. But keeping them in this order helps us to see what's going on. So again, I've got the derivative of my derivative times the same thing plus the same thing times the derivative of g. And make sure that you see what I'm doing here. It's this thing plus this thing, where I differentiate one of them, differentiate the other one, and that is the product rule. Okay, so now that we've got that, well, let's differentiate this. What is the derivative of f prime of g? The derivative of f prime of g is the second derivative times the derivative of what I was doing in the first place, right? The inside function. If this is the outside function, this is the inside function, the derivative of this is going to be the second derivative times the derivative of what was inside. This thing stays the same. Plus, this stays the same, and the derivative of g is the second derivative of g. Now we can simplify. We don't need all those green brackets. This is going to be the second derivative of g times 2 of these, giving it squared, plus the first derivative times the second derivative. And this right here is identical to this right here. The second derivative of my function is the second derivative of the outside, times the square of the first derivative of the inside, plus the first derivative of the outside times the second derivative of the inside. So that's what this thing is right here. Now, how do you use that? I don't know if you even need to, but let me show you kind of a neat little thing. If you have this h of x equals this composite f of g of x, we recognize that my outside function is 6g cubed. Differentiate that, you get 18g squared. Differentiate that, you get 36g. The inside function is g of x equals 2x plus 5. Differentiate that, you get 2. Differentiate that again, you get 0. And now you just build what you see here using these 6 things as you need it. In fact, you need the first and second of the outside, first and second of the inside. It is the second of the outside times the first of the inside plus the first of the outside times the second of the inside. And simplifying this, the g kind of rides along until we get everything simplified. This is 0, this drops out, which is very similar to the one that you're working through where your acceleration is 0. That drops out. You've got 4 times 36 is 144g. What is g? Oh, that's right. G is your 2x plus 5. We have our 2x plus 5, which happens to be the exact same thing as this. Is this useful? I don't know. To get the second derivative before, we actually had to do the first derivative and the first derivative again. And, you know, if this were like to the 13th power, something like that, we would have, this wouldn't have been a nice simple 2. It would get kind of ugly. This process right here might seem a little bit easier. I didn't get to the rest of this, but this seemed to be the only issue that you had at this point. If you need help with the other ones after this, then go ahead and let me know.